Alkyne metathesis. A metathesis is a bimolecular process involving the exchange of bonds between the two reacting chemical species. An alkene metathesis is also called as olefin metathesis, is basically a reaction which involves redistribution of olefinic bonds, basically the double bonds. Here in alkene metathesis, the double bond is going to break and the fragments that are obtained are rejoined to form new double bonds between the sp2 carbons. And three people, Grubbs, Schrock, and Chauvin, were awarded Nobel Prize for their work on metathesis reaction. Here is an example for the alkene metathesis reaction. This is our first alkene molecule, and this is our second alkene molecule. And let's label the sp2 carbons here. These are all our sp2 carbons. We are going to break these double bonds, these two double bonds here, and we are going to unite the two sp2 carbons. So we are going to unite these together. So when it gives that, this is going to give us a new alkene. And similarly, when we unite these two sp2 carbons together, this is giving us ethylene molecule, which is another alkene molecule. So here are the two new bonds, two new double bonds that are created. This can also join in another way. Say, for example, if you're going to join these two sp2 carbons together and these two sp2 carbons together, then it's going to result in the formation of the starting material itself. So let's say that you're going to join these two sp2 carbons together. This is basically our starting material. So the sp2 carbons can be joined in different ways. So you can get either the new alkenes or the reactant itself. In general, the reaction with terminal alkenes will always give us the best yields in the alkene metathesis reaction because this is going to result in ethylene as one of the products, right? Because ethylene is a gas, it can be easily removed from the reaction mixture, driving the reaction in the forward direction. As you keep removing ethylene, more and more products will be formed. In order for alkene metathesis reaction to happen, we need to have a transition metal catalyst, and the catalyst that we use for the reaction is Grubbs catalyst, which contains ruthenium. And wherever there is a possibility for the formation of the E and Z isomers, then both the products will be formed. You can also do the alkene metathesis reaction with two different alkenes. In the previous examples, we took only one alkene, one type of alkene, and two of those molecules reacted together to give us the product. But here the reaction can also be performed with two different alkenes. If you want, let's arrange this. So here are sp2 carbons, and we are going to break these bonds and we are going to form these two new bonds. Okay, and you can say 1, 2, 3, 4, 5 carbons are there, and your product is going to have 5 carbons, and this is symmetrical, right? So because of which it's going to give us only one product. If the reactant is a diene, then a ring closing metathesis can happen. So now let's again find out how this cyclic structure is formed. Okay. So here are sp2 carbons. We are not going to touch the sp2 carbons in the benzene ring. We are not going to break any of these double bonds. Okay, it's not going to be possible because we know that this is an aromatic structure which is more stable, and there's no way that we can break this double bonds under these conditions. So we are going to break these two double bonds and we are going to put two new double bonds here. Okay, once we break the double bonds. So that's going to give us this cyclic structure and also the ethylene molecule. Look at this. This is also a terminal alkene, which is definitely going to give us ethylene molecule. Coming to the mechanism for alkene metathesis reaction. The alkene metathesis reaction happens in two phases, and both of these phases are identical, where it's going to lead to the formation of a metallocyclobutane in both of these cases. This slide shows only the phase 1. Here is the representation for Grubbs catalyst, and this is the alkene molecule. Since the alkene molecule has got two different sp2 carbons, the metal from the Grubbs catalyst can attack either one of those sp2 carbons, and accordingly two different metallocyclobutane structures can be formed. Once the metallocyclobutane structure is formed, it's going to undergo ring opening reaction to form two metal containing intermediates. So you can see that in each of these intermediates, the metal is connected to the sp2 carbon. And in the second phase, the two new metal containing intermediates will react with the starting material to form two new metallocyclobutanes, which will undergo ring opening reactions to form the two new alkenes. So here are the two new alkenes. Even alkynes can undergo metathesis reaction, for which we needed to use the shock catalyst, which is a catalyst containing molybdenum and tungsten. So here is our alkyne molecule. Let's see how we get two different products. This is our sp carbon. And let's also draw the other alkyne molecule. These are our two other sp carbons. Okay, and we have to break this triple bond, and we are going to create these new triple bonds. And that's how we get these two compounds. So if you take a look at this, 1, 2, 3, 4, 5, 6 carbons. Yes, this molecule has got 6 carbons. Right?